Hi, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so we are at the end of the last final chapter, or we call subtopic for chapter 6 or topic 6, data description, lecture 3 of 3, with the subtopic of measures of dispersion. Okay, so in this video, we are going to find and interpret of the variance and standard deviation for ungrouped data, variance and standard deviation for group data, and find interpret of Pearson coefficient of skewness. So then, we look into the variance, standard deviation, and range for the both of group and ungrouped data. So example 1, okay. Example 1, look at data of data 167899696. Okay. So mean equal to 7, so it is 6 plus 7 plus 8 plus 6 plus 9 plus 6 divided by 1, 2, 3, 4, 5, and 6. Okay, so 6 plus 7 equal to 13, plus 8, 21, plus with 6, 27, plus with 9, 36, plus with 6, 42. Okay, so 6 plus 7 plus 8 plus 6 plus 9 plus 6 equal to 42 divided by 6 equal to 7. Okay, which is 42 divided by 6 equal to 7. And look at this one here now. 5, 7, 2, 6, 13, and 9. Where mean is also equal to 7. Okay. So look at this one here now. From 2, 4, 6, 8, 10, 12. And also here 2, 4, 6, 8, 10, and 12. Okay. So for the first data, if I use, we call the purple ink for the data number 1, first add 6, 7, and 8, 6, 9, and 6. Okay, so you can see here the data stated in the range of 6 until 10. Okay, and then now here 5, 7, and 2, 6, 13, and 9. Okay, what can you see here now? Most of data in data 1 are around mean value, where mean equal to 7 is around here, meaning the data is very close to the mean equal to 7, but then data 2 is more spread away from the mean, where mean equal to 7 here, but then the data, the lowest is 2 and the highest the highest is 13. So it's spread. So the difference in the spread can be determined by the measure of dispersion. Okay, so we will look into the common measures of dispersion, range, variance, and standard deviation, where the range equal to largest value minus the smallest value. Range is not a good measure of dispersion because it is influenced by the extreme values and calculation does not cover all observation. And what about variance and standard deviation are most useful and widely used measures of dispersion. Okay, although they are influenced by extreme values, the calculation cover all the observation. Okay, so we should think that you may read all this. Okay. Okay, so the standard deviation measures how spread of the values in data. If all data are close to the mean, then the standard deviation is close to 0. If many data points are far from the mean, then the standard deviation is far from the 0. Okay. So then the variance summation of xi minus x, the average or mean, squared divided by n minus 1. Okay, so we're not going to discuss all this formula one by one. So we are going to just recall, focusing on the solution. Okay. Okay, and standard deviation equal to the square root of variance. Okay, now given here, calculate the variance and standard deviation for following set of sample. Okay, so let's say for data 1 and data 2. For data 1, we got 16, 10, 9, 2, 5, 2, and 7. Okay, so from the formula of the variance, s squared equal to summation of x squared minus summation of x in bracket square divided by n, and everything divided by n minus 1. Okay. There you go. Okay, so it means that here we need to find out summation of x squared and summation of x in bracket square. So summation of x squared, this is an x. So x squared, so 16 squared equal to 256. 10 squared equal to 100, 9 squared 81, 2 squared equal to 4, 5 squared 25, 2 squared equal to 4, and 7 squared 49. Okay, so the summation of x squared for this one here. So summation of x squared equal to 256 plus 100 plus 81 plus 4 plus 25 plus 4 plus 49. Okay, so then 256 plus 100 plus with 81 plus 4 plus 25 plus 4 plus 49 equal to 519. Okay, and then summation of x equal to 16 plus 10 plus 9 plus 2 plus 5 plus 2 plus 7 equal to 16 plus 10 plus 9 plus 2 plus 5 plus 2 plus 7 equal to 51. So the summation of x in bracket square, which is 51 square. So then 51 square equal to 2601. Okay, so variance equal to summation of x square Okay, summation of x squared here equal to 519 minus 51 squared or 2601 divided by 7. 1, 2, 3, 4, 5, 6, 7 divided by 7, and everything divided by 7 minus 1 equal to 6. So then the result of this 519 minus 51 squared divided by 7 and everything divided by 6 equal to 24.571. Okay, 849. So standard deviation S equal to square root of variance 24.571,849 equal to 4.957. Okay, now for data 2, data 2 here, where x is 10, 32, 8, 12, 14, 36, 20, 8, 40, 4, 32, and 1. Okay, the same step as this one here, square x squared, square every single value that we have here, and then summation of x squared we get here, and summation of x, and square the summation of x, then substitute into the formula here. So you use the step as this one here into data number 2. So I straightly come up with a solution of this. Okay, I leave a space here for you to fill in x squared, summation of x squared, and summation of x, and square the summation of x. So then straightly S2 equal to 5929 minus 217 squared divided by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and everything divided by 11, where it's equal to 182.265. So standard deviation, this is variance, and standard deviation here equal to square root of 182.265 equal to 13.5. So from these two results, 13.5 and 4.957, so hence data 2 is more dispersed than data 1. Range with upper boundary of the last class of the what you call last final class minus lower boundary of the first class. Okay, interquartile range for third quartile minus the first quartile, and variance as you see a screen here, and standard deviation. So the example 1. Find the range, variance, and standard deviation of this data. Okay. Okay. So from class intervals and frequency, then come up with the class marks. Class mark is the midpoint of the class 1 and 3. So 1 plus 3 divided by 2 equal to 4 divided by 2, then equal to 2. With midpoint of 4 and 6, 4 plus 6 equal to 10, divided by 2 equal to 5. So class marks, we can also state this one as a midpoint. Okay, midpoint of x. And then find out the f multiplied with x squared. f the frequency, and x squared. 2 squared equal to 4. 4 times 5 equal to 20. 5 squared is 25 times 3 equal to 75. There you get fx squared. Shall I? Okay, never mind. I think that you can get what I'm trying to say here. F multiplied with x squared. X equal to 2. So then 2 squared, okay, 2 squared multiplied with f, which is 5. So 2 squared equal to 4. 4 times 5 equal to 20. Okay, f again equal to 3 multiplied with x squared, 5 squared. 5 squared is 25. 25 times 3 equal to 75. That's it. So f times x, so 5 times 2 equal to 10. 3 times 5, 15. 2 times 8 equal to 16. So summation of fx equal to 204, and summation of f times x squared equal to 2676. Okay. There you go. Now, the solution. Variance. Okay, for variance equal to summation of fx squared minus summation of fx squared divided by summation of f and divided by summation of f minus 1. So please refer all these values from the previous slide. Okay, summation of fx here, summation of fx squared here, and also summation of f is 21. Okay, let's substitute the value one by one, which is 2676 minus summation of fx in bracket square 204 divided by 21 divided by 20, is equal to 34.71. Use your calculator to get its answer here. And as standard deviation equal to square root of variance, which is equal to square root of 34.71 equal to 5.892. Okay. Now, find the mean interquartile range variance and standard deviation for data below and interpret the standard deviation. Okay, now I need to sketch all. Okay. So okay, then so the first one here, which is marks. Okay, marks, and then x or the class marks or the midpoint. Okay, x. Then the frequency, and then cumulative frequency. What's next? F multiplied with x. F multiplied with x. Okay, let's say if I add another column of this, of x squared. Okay. And this is for f multiplied with x squared. Okay, so the marks x in between 0 up to 20, okay, 20 to 40, 40 up to 60, the size, the class, 60 to 80, and 80 to 100. Okay. So then x, let's say midpoint here is 10, 30, 50, 70, and 90. And frequency given that just now, 9, 29, 42, 26, and 40. Okay, so let's find the sum of the frequency. 9 plus 29 plus 42 plus 26 plus 14 equal to 120. Okay. Okay, this is a frequency. Then the cumulative frequency, first is 9. 9 plus 29 equal to 38. 38 plus 42 equal to 80. 80 plus 26, 106, and 106 plus 14, 106 plus 14 equal to 120. So you can see here now the n of the cumulative frequency equal to the numbers of frequency here. Okay, and then next, x squared, 10 squared is 10 times 10 equal to 100. 30 squared equal to 900. 50 squared, 2500. 70 squared, 4900, and 90 times 90 equal to 8100. Okay, so F9 times 10 equal to 90. And then 30 times 38, 170. 50 times 80. Oh no, I'm sorry. It's not that 38 times 30. It is 29 times 30. Okay, 29 is F multiplied with X. F, this one here, multiplied with X. So 29 times 30, 870. 42 times 50. 42 times 50 equal to 2100. So 26 times 70, 1820, and 14 times 90, 1260. Okay, now we get a column for F multiplied with X squared. So there's a column of F and column of X squared. So 9 times 100 equal to 900. Then F29 times with 900. Okay. 29 times 900 equal to 26,100. 42 times 2500. 42 times 2500 equal to 105,000. So we continue here 127,400, and then F14 multiplied with 8,100 equal to 113,400. Okay, so the total of this, the total of frequency 120, the total of F times X equal to 6140, okay, and summation of F times X squared equal to 372,800. Okay, so summation of F equal to 120, the summation of Fx, okay, summation of Fx here, and summation of Fx squared, as you see here now, 372,800. Okay, so now mean equal to 6140 divided by 120, or it is summation of Fx divided by summation of F. And 6140 divided by 120, it is 51.17. And first quarter, okay, from cumulative frequency 120, quarter times 120. 120 divided by 4 equal to 30. Okay, so then 30, it lies in between from 9 to 38. From 9 to 38, so then the lowest frequency, the lowest class here is 20, and then the frequency, cumulative frequency before is 9, and frequency of the class here, the first quartile is 29. Okay, so the size class equal to 20. Okay, now it is 20 because 30 is lies in between, okay, before the cumulative frequency of 38, so between 9 to 38, the 30 is between here, so this is our class target. Okay, 20 plus 1/4 times 120 minus 9. 9 is the cumulative frequency before the first quartile of the class. Okay, before the cumulative here is 9. Okay, and then divide by 29, the frequency of the first quartile, here 29, and multiply with 20, the size of the class, 20 to 40, the difference is 20. Okay, it is equal to 34.48. And the third quartile equal to, okay, 3/4 times 120. Okay, so, okay, for this one here, 120 divided by 4 is 30. 30 times 30 equal to 90. So 90 is between 80 and before 106. So this is the class that we're talking about. So now the lowest we call minimum of this here is 60 plus with 3/4 times 120 minus, okay, now the cumulative frequency before the third quartile of the class, this is the, we call 3/4 or third quartile, so the cumulative frequency before is 80 minus 80 divided by the frequency of third quartile here is 26. And the size class all the same, which is equal to 20, then equal to 67.6. There you go. Okay, so from this data, we continue our discussion. The solution of this variance equal to summation of fx squared, and summation of fx 6140 in bracket square. We'll count it here. Summation of fx squared minus summation of fx squared divided by summation of f, and everything divided by summation of f minus 1. So summation of fx squared equal to 372,800 minus 6140 squared divided by summation of f is 120, and 120 minus 1, 119. Okay, so use a calculator and this will give you 492.75. Okay, and standard deviation equal to square root of variance 492.75, which is equal to 22.20. Okay, look at it here now, where mean equal to 51.17 and standard deviation is 22.20. So we're going to come up with a conclusion. We look at this standard deviation and mean. So many data points are far from the mean. Okay, standard deviation is very far from the mean. Okay. Then next, Pearson coefficient of skewness. Okay, equal to, with the formula of 3 times mean minus median divided by standard deviation, or mean minus mode divided by standard deviation. Okay, so when distribution are skewed, the mean generally lies between the mode and median, so the formulation is satisfied then. Okay. So anyway, you have all this recall stated in your lecture notes. Okay, and this one here we call symmetrical or called normal distribution. Okay, so determine the Pearson coefficient of skewness for the following data. Hence, can you conclude? So now class, the first formula of Pearson coefficient, okay, equal to 3 times mean minus median divided by standard deviation, and another formula which is mean minus mode divided by standard deviation. Okay, the thing is, look at the parameter here is mean, median, standard deviation, mean, mode, standard deviation. Let's take a look at the mode. Means that the numbers that appears most. 2 appears once only, 3 appears 2 times, 5 appears 2 times, 4 once, 6 once. So there are 2 modes where 3 and 5, okay, 3 and 5, every of these appears twice, 1, 2, 1, 2, meaning there is no one mode. There are 2 modes. Then we cannot use this formula for this case. We can only use the formula of this. So 3 times mean minus median divided by standard deviation. So then mean equal to 2 plus 3 plus 3 plus 5 plus 4 plus 5 plus 6 divide by 1, 2, 3, 4, 5, 6, 7 equal to, okay, is 28 over 7 equal to 4. Then median equal to 4. How will you find out the median here? Okay, 2, 3, 3, 3, 3, 4, 5, 5, 6, 5, 5, 6. So number of data here 1, 2, 3, 4, 5, 6, 7. And equal to 7, and 7 is odd numbers. Odd numbers means that there is a value that exactly in the middle between 3 numbers here. Okay, on left side there are 3, where 1, 2, 3, and also on the right side there are also 3 numbers here, 1, 2, 3. So then the median is exactly, middle here is 4. Okay. And find the standard deviation, where S equal to 1.4142. Okay, so then the Pearson of skewness, we call Pearson coefficient of skewness equal to 3 times median, 3 times mean. Mean equal to 4. Mean equal to 4. Minus median also equal to 4 divided by 1.4142. So 4 minus 4, 0, times 0 divided by 1 something equal to 0. So means that the data is symmetrically distributed. Okay. So now, for example 2, from above data, find the mean, mode, and standard deviation. Find and interpret the Pearson coefficient of skewness. Okay, so then we are copying all again. Frequency here 3, 2, 6, 4, and 1. So the summation of F equal to 3 plus 2 equal to 5 plus 6, 11 plus 4, 15 plus 1 equal to 16. Class marks the midpoint of 6 and 8, which is 7. Midpoint between 9 and 11, 10. Yes. 13, 7, 10, 13, 16, and 19. So F times X. F times X, 3 times 7, 21. 2 times 10, 26 with 13, 78. 4 times 16, 64. And 1 times 19 equal to 19, and the summation of fx equal to 202. Okay. Now is for f times x squared, meaning f times x squared. 7 squared is 49, so 3 times 49 equal to 147. 10 squared equal to 100. 100 times 2 equal to 200. 1014, 1024, and 361. And the summation of fx squared equal to 2746. Okay. Now, the mean, the mean, average or x bar equal to summation of fx divided by summation of f equal to 202 divided by 16 equal to 12.625. Then B, median, the mode class. Okay, the mode class. Mode means that with the highest frequency. So according to this table, a class with the highest frequency here is 6. Okay, with the highest frequency equal to 6. 12, size of class 12 until 14. Okay. The mode class is 12 to 14. Okay, so we list down here the mode equal to LKL, which is 11.5. Yes, 12 minus 0.5, 11.5. 12, the lowest class, minus 0.5 equal to 11.5. So 11.5 plus width, the difference. Okay, 6 minus 2 equal to 4, and 6 minus 4 equal to 2. D1 and D2. Okay, so D1 is 6 minus 2 equal to 4 divided by D1, 6 minus 2 equal to 4 plus with 6 minus 4 equal to 2 and multiply with the size of the class, which is equal to 3. Okay, so it gives us here 11.5 plus width, 4 plus 2 multiplied with 3. Okay, which is 13.5. Okay, so the mode is 13.5. The standard deviation, okay, variance first, we look and find the variance, which is summation of fx squared minus summation of fx squared divided by summation of f, and everything divided by summation of f minus 1. Okay, so please refer to the table that we complete just now, and it gives us 2746 minus 202 squared divided by 16 divided by 60 minus 1 equal to 15. There you go. Okay, 202 and 2746, where the summation of f equal to 16. Okay. Okay, now this gives you 13.05. So standard deviation equal to summation of square root of x squared. Standard deviation of s equal to square root of variance, which equals to square root of 13.05 equal to 3.612. Okay, then so we agreed that we're going to use the coefficient of skewness using 3 times mean minus median divided by standard deviation. Okay, let's refresh. when mean equal to 12.625, the median okay, then we use the formula according to what we search or seeking just now, because we find the mean and mode and standard deviation. So mean, mode and standard deviation are equal to the formula of mean minus mode divided by standard deviation. Okay, so the mean here is 12.625 minus mode 13.5 divided by 3.612 equal to negative 0.242. So then the distribution is slightly negatively skewed. Okay. Okay, so that is what we call the lecture for this time. Okay, so again, for percent coefficient of skewness is based on what is the data that given to us, and one of the examples shows that we cannot use the mode because there is no mode in the data, or might be the mode is more than 1. So we move to the other formula of this with 3 times mean minus median divided by standard deviation. Okay, so that's all for today, and I do hope that this video helps you a lot, and please don't forget to continue with your tutorial and PS Bank question. Okay, that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.